First of all, what is self-energy? Self-energy is nothing but the energy contained in the system or contained by the system. The energy present in the system, any kind of a system that is. Okay. Now, suppose I have 2-point charges. I'm just giving these examples. The derivation
Yes, sir.
is different. The concept is same, but first I am trying to give you examples where we will apply the same thing for point charges. So there are 2-point charges, identical point charges placed at points A and B. Okay.
Yes, sir.
Now, this ABCD is a square of side A. Okay.
Yes, sir.
Then, suppose I have a point charge Q1 at infinity. Somewhere at infinity, I have a point charge Q1.
Yes, sir.
From the infinite to the point C, if I want to bring my charge. Okay.
Yes, sir.
From infinity, if I want to bring to point C, will the charge come by itself? So what is the entire situation over here? There are two charges, there are two identical charges, plus Q placed at vertices A and B of a square of side A. There is a third charge, Q1, which is right now present at infinity.
Yes, sir.
I have to bring that charge from infinity to point C.
Mm.
First question, will the charge come by itself?
No, sir.
Why?
It's at infinity distance. There won't be any energy between.
The conceptual why answer to that why is, I told you which is the most important physical quantity in entire of electricity and magnetism.
Potential energy.
Not energy, potential.
Potential.
Not energy, potential. The potential at point C is greater than the potential at point infinity. Therefore, the charge will not be able to come by itself.
Yes, sir.
You can tell next year, I have learnt entire physics by myself.
Yes, sir.
So, because the potential at point C is greater than potential at infinity, the charge cannot, a positive charge cannot travel by itself from
Yes, sir.
infinity to point C. If the potential at infinity is greater than the potential at point C, then the positive charge, if you slightly push it, gives some small kinetic energy. Negligible kinetic energy is also enough. It will automatically come.
Yes, sir.
Higher potential to lower potential, automatically it will go. We saw that, right? Two lines, electric field, high potential, low potential, place a point charge, it will go by itself.
Yes, sir.
Right? So the reason why the point charge Q1 will not come from infinity to point C by itself is basically because the potential is greater at point C. Simple. Okay. Next. Okay. Because it can't come by itself, somebody has to bring it. That logic is clear to me.
Yes, sir.
Find the work done by the external agent to bring that fellow. Find the work done by the external agent to bring that fellow. Okay.
Yes, sir.
So now what I will say is, I know work done is equal to
Energy potential. and
But
arrive with respect to the state.
here I know that I can write the exact equation, but I am writing work done. I can find it by using my change in potential energy, right?
Yes, sir.
And let us say that we are keeping the change in kinetic energy zero. Even if that fellow doesn't mention, we are bringing a static charge from infinity to point C. When we bring it to point C and placing it there, that means its velocity again finally is zero.
Yes,
And
sir.
initial is also zero. So usually they will not mention this. This is, we have to get it by our understanding. Now why I am saying I want to find the work done using my change in potential energy. I'm saying using rather than writing a proper equation. Actually, I know that you already know that we can say work done by external agent is positive of change in potential energy of electrostatic potential.
Yes, sir.
You know that. If I have same subscript, then I'll have minus sign. If I have different subscript, then I'll have plus. But let us look at this situation in a logical way. Okay. So I want to find the work done using my change in potential energy. Now I don't know if positive, negative, all these stories. So what is the initial potential energy of the system? Of the system in the sense,
It will be only between A and B.
good. So let us write it thoroughly over here. The initial potential energy of the system is equal to
Yes, sir.
kq square by A. That is only between A and B.
Yes, sir.
What is the final potential energy of the system?
It will be between
Of course,
AP, AC, BC.
between A and B is anyways there kq square by A. Now between B and C, what potential energy will be there?
Sir, A, I mean,
kq
between
q1
that common. Yes, sir.
divided by A.
Yes, sir.
Between A and C, what will it be?
Plus KQ by A root 2.
A root. Obviously, we can see that this value is greater than that value.
Yes, sir.
That is because the potential at C is greater than potential. Both are same.
Yes, sir.
Both background meaning is the same. Representations are different. So what is the change? Obviously, by looking at it, I know this is 100 joules, that is 50 joules. So I'll do 100 minus 50, right? I'll do higher minus lower.
Yes, sir.
So what will I get? KQ Q1. I'll take divided by A also common. I'll get 1 plus 1 by root 2.
Yes, sir.
Now this is the extra energy between initial status and final status, right?
Yes, sir.
So that much amount of energy is what is required. So I'll simply write this is equal to work done external. Are you getting my point?
Yes, sir.
Example, this initially has 50 joules. The system finally, suppose I have 120 joules. Okay.
Yes, sir.
So I need to have, how much should I spend on it? 70 joules.
Yes, sir.
Is this clear?
Yes, sir.
Or I could have said it by the definition, or by our previous work done by external agent is equal to change in potential energy. Change is basically final minus initial in physics, and subtract those two. So we can look at it that way also, or we can look at it through our common sense also. That fellow has 1 laddu, this fellow has 5 laddus. The change in number of laddus is 4, so somebody has to give them laddus. So the number of laddus given by the external agent is 4. That's it.
Yes, sir.
Xerox.
Third, I have AR by x square plus R square integral d theta square, sir.
Why do we want all those things? What is the potential energy when it is at the center? K capital Q small q by R.
Yes,
What
sir.
is the potential energy when it is at infinity? Zero. So the work done is K capital Q by R.
I'm entering this set.
My last question I was explaining that I was trying to explain you that only. Don't do PhD. You don't need to do PhD in everything. Don't do extra physics. I know electrostatics. Let me do PhD. Not required only. I'm giving the example again and again, and you are going into PhD mode back to. Now, very difficult question. There are two identical loops. There are two identical loops having uniform charge distribution. The total charge on each of the loop is capital Q. The radius of each loop is small a. Find the work done to take a point charge small q from center O1 to the other center O2.
Yes,
Both
sir.
the loops are placed parallel to each other. Everything is identical. Symmetry exists.
Yes.
Hello everyone. Welcome to Veracious Academy. My name is Anil Kumar. I am an alumni of IIT Bombay. I have done my BTech from Mechanical Engineering. I have been teaching physics for the past decade for JEE Mains, JEE Advanced, Neet UG, and other competitive exams. If you're interested to attend my sessions, please find the contact details in the description below. Let's get started with this lecture. Enjoy the video. Work done is 0. I gave the question so that you'll give the answer immediately. Work done
Yes,
is
sir. Should be zero.
because the potential energy of the system when the charge here is identical to the potential energy when the charge is placed over there.
Yes, sir.
Initial potential energy is equal to final potential energy, therefore the work done is 0. Or you can see the potential at O1 is equal to the potential at O2. Fine?
Yes, sir. We should
Therefore,
take here the Q, capital Q, and one more time Q, capital Q. But anyway, work done is zero.
identical, right? Everything is
Yes.
identical. So, the work done can be written as charge into change in potential, Q into delta V.
Yes, sir.
So the reason why I came to work done is equal to change in potential energy is because the definition of potential, instead of U, we can substitute it as Q into V, right?
Yes, sir.
And if charge is a constant, it will come out and you will have work done as Q delta V.
Yes, sir.
Okay.
Yes, sir.
Now, should I erase this?
Yes, sir.
Now let us go to self energy. Simply, this is exactly what we are doing in our self energy also. Okay. So there is a solid sphere. Obviously, now you have heard word conducting, non-conducting. So there is a solid sphere of radius r.
Mm-hmm.
What's that noise?
Pushing bed inside.
There is a solid sphere of radius small r. Okay. Now,
Yes, sir.
how are we creating this solid sphere? We take mud, make a ball out of it, then put more mud on it, and make it a bigger one, right? So
Yes, sir.
similarly, how we are making a solid sphere is by adding layers on this solid sphere. So I already have a solid sphere of radius smaller. Now I'm going to add a thickness of dr everywhere around this solid sphere.
Yes, sir.
Okay.
Yes, sir.
And this is a sphere. That means it is not just 2D, it is 3D.
Yes, sir.
So how much actually am I adding? The surface area of the sphere into the thickness, right?
Yes, sir.
The surface area of the sphere into the thickness. Actually, what is it that I am adding? I am adding volume, not length and area.
Hmm.
Initial volume is 4 by 3 pi r cube, small r cube, and I am adding another dV to it.
Yes, sir.
How will I get my change in volume dV that I have added? The surface area 4 pi r square into the thickness dr.
Yes, sir.
Correct? Okay.
Yes, sir.
Now, we wanted to find the self energy. What is self energy? To add this, so suppose this fellow has a charge of dq. To add this layer, I'll have to do some work. The layer is not going to come by itself. So
Yes, sir.
from where am I getting this layer? From somewhere, that is infinity. We
Yes.
don't have a charge dq anywhere nearby. That means, that implies that we are bringing it infinity. So from infinity, when I am bringing the charge dq and putting it on my sphere, I will have to do work.
Yes, sir.
Why?
Because the potential here is more.
Good. The potential at the surface is more than the potential at infinity. The potential at infinity is 0. What is the potential at surface?
It will be KQR.
Kq by r. Okay.
Yes, sir.
So suppose the charge right now that I have is, let's say, capital Q,
Yes, sir.
or we will make it capital Q later. Suppose the charge that I have right now is small q, because I have a charge small q and I'm adding dq, right?
Yes, sir.
It's like x plus dx. So I have a charge q, and on that top of it I am adding dq, and I know what is work done. Work done is equal to change in potential energy, you can say, or you can say q into delta v, right? This also you can say.
Yes, sir.
But if you look at it from here, I can say work done is equal to integral of, I'm writing integration because you know that we are going to construct a sphere out of it, right?
Yes, sir.
And let the sphere that we are constructing have a radius of capital R.
Yes, sir.
Now, the work done, what is the work done to bring this charge dq? Is the charge dq into change in potential. Delta V.
Yes, sir.
Change in potential. How much is delta V? K small q by small r.
Yes, sir.
Because that is the potential at the surface. Potential at
Yes.
infinity is anyways 0.
0. Yes, sir.
Is this clear?
Yes, sir.
Watch the recorded. I'll post it. I'll have to do a lot of editing, but watch the recorded thoroughly in this step. I'll explain this again. Okay. After this, life is simple. After this, it is analytical. Any mathematics student can do.
Yes, sir.
Writing this itself is what is important. So here I wrote work done is equal to q dv, right? This one.
Yes, sir.
But actually here the charge that I am bringing is not q. The charge that I am bringing is dq.
Yes, sir.
And into dv I should write.
Yes, sir.
So I was just, why did we solve those previous questions? To create a basic structure for this question.
Yes, sir.
Bringing charge dq from infinity to this point is equal to charge dq into the potential difference at infinity and at this point.
Yes, sir.
So what is the potential difference? K small q by small r into what is the charge that I am bringing is dq.
Then you should write. Yes, sir. I got it.
We should write kq plus dq by small r.
No.
What?
No, sir, I got it.
The potential on the surface of this solid sphere having a charge small q, radius small r, is k small q by small r.
Yes, sir.
Into the charge that I am bringing to that position is dq.
Yes, sir.
The work done is charge dq into the potential. Is this clear?
Yes, sir.
This is
Yes.
actually potential difference. Basically, k small q by small r minus 0. Potential at infinity is 0.
Yes, sir.
Now, rest is just mathematics. Integral of. We said it's a uniform solid sphere.
Sir, we are bringing dq, that's why it is dq into the delta.
Correct.
Yes, sir.
Okay. If I'm bringing small q, it will be small q into delta v. If I'm bringing q1, in previous question we did bringing q1 from infinity to here. So it was q1 into delta v.
Yes, sir.
So here I am bringing dq, therefore it is dq into delta v. Okay.
Yes, sir.
Now, we said it is uniform solid sphere, that means my rho is constant.
Yes, sir.
Rho is charge per unit volume. What am I
Yes.
constructing over here? I am constructing a big solid sphere whose total charge is capital Q and the total radii is capital R.
Yes, sir.
I am constructing a solid sphere by adding dq's on it, on top of it, so on and so forth. I'm constructing a solid sphere of total charge capital Q and radius capital R.
Yes, sir.
So I can say my rho is equal to total charge divided by volume.
Yes, sir.
Or I can also write it as dq by dv.
But then it should be q plus dq. No, sir. I mean, total charge, like after bringing, we'll have q plus dq.
So on and so forth, right?
Yes, sir.
So I have 500 laddus and now every day I am adding one laddu each. And so on and so forth. Now the total can be 1500 laddus depending on number of days that I am adding.
Okay, okay. Yes, sir.
So the total charge is capital Q and the total
Yes,
radii
sir.
is capital R. What am I finding self energy for? I am finding the self energy for a solid sphere of radius R
Yes, sir.
and having a total charge of capital Q. How am I
Yes.
finding the self energy? By finding the work done to bring a small charge dq from infinity to the surface of the sphere.
Yes, sir.
Now after adding this, I will go back, bring furthermore dq, add it on top of it, so on and so forth. Now I am making bigger spheres. This is like ice falling on a mountain slope.
Yes, sir.
As it rolls down, it keeps adding more and more ice on its surface.
Yes, sir.
So like this here, what I'm doing is I'm adding more and more charge on the surface, making it a solid sphere of radius capital R and total charge capital Q.
Yes, sir.
Bringing each dq is my small work done. The total work done to bring the total charge from infinity to make that solid sphere is the self energy. When
Yes,
I'm
sir.
bringing this small dq from infinity to this point, whatever work I am doing is the energy that is stored inside it, right?
Okay, yes, sir.
Right? So the energy that is stored or that is added or that is given to the system when I'm bringing this charge dq from infinity to the periphery is the energy stored in the system, added to the system.
Yes, sir. Yes, sir.
And when you integrate it, You are getting the total energy stored in the system.
We are getting work done.
Yeah, we are getting work done.
Okay, I got it.
Which is the total energy stored in the system.
Yes, sir.
The total energy which is stored in a particular solid sphere is its own self-energy.
Yes, sir.
Self-energy of a solid sphere is the total energy stored in a solid sphere, which is nothing but addition of all the work done to bring all small dqs to from infinity to the periphery.
Yes, sir.
dw1, dw2, dw3, work done in bringing each dq from infinity to this periphery. Add all of them.
Yes.
How am I adding? By integrating.
Yes, sir.
Add all of them. So the addition of all of those works is the total energy that is stored in the system. The total energy which is stored in the system is itself called self-energy. Clear?
Yes, sir. So we need to put the limits from R to capital R. And then
We took a situation of smaller adding dr width. But actually we are constructing the entire solid sphere from the scratch.
Oh.
0 to R.
From the Z. From
smaller to capital R will only give me the work done to bring charges between the radii small r and capital R.
Yes, sir.
But if I want to find the work done in bringing any charge, the total charge that is present. So this clarity should be there. Self energy of solid sphere is the energy stored in the solid. Potential energy stored in the solid. The potential energy stored in the solid sphere is nothing but the addition of all the work done when the charge dq is being brought from infinity to periphery.
Yes, sir.
So when every day I'm bringing 2 books to your home. Every day I'm bringing newspaper to your home and giving it. The total number of newspapers that your home has is the summation of all the newspapers that has been given to you.
Yes, sir.
Simple, right? The total energy, potential energy stored in a solid sphere is equal to the summation of all the energies required to bring those charges from infinity to the periphery.
Yes, sir.
Okay, now moving on. What is dq? Oh, by the way, this is also small q by 4 by 3 pi r cube. Small r cube.
Yes, sir.
Now, what is dq? dq is
Rho dV.
Rho dv. dv is 4 pi r square dr.
Yes, sir.
What is q? Rho into 4 by 3 pi r cube. Now I need to substitute these over here. So in place of dq, I'll substitute that. So first I have k by r. Okay.
Yes, sir.
What is dq? Rho into 4 pi small r square into dr. What is small q? Rho into 4 by 3 pi r cube.
Into k by. Okay, you wrote them.
K by r I wrote.
Yes, sir.
And this thing is from 0 to capital R. Is going to give me the self energy of the entire sphere. Okay. This is going to give me the self energy of the entire sphere, capital Q charge having capital R radius. Let us take the constants outside. 16 pi square by 3. 16 pi square rho by 3 are the constants, and k also.
Yes, sir.
4 pi is 16 pi square divided by 3. Rho square is there, in fact, rho and rho. Okay.
Yeah, sir.
Rho and rho. There are two rows.
Yes, sir.
And a k. K is done. Rho is done. 4 pi, 4 pi. Rho is done. 4 pi, 4 pi. 3 is done.
Yes, sir. R power 5 d.
R power 5 d.
R will get cancelled in the denominator.
The integral of 0 to r. What should I get? R power?
R power 4.
4 dr. So my answer will be r power 5 by 5, right?
Yes, sir.
5 3s are 15. I will have 16 by 15. Pi square, rho square, k. Yeah?
Yes, sir.
Pi square, rho square, k into r to the capital R to the power 5. Correct?
Yes, sir.
But my rho is equal to capital Q by 4 by 3 pi r cube.
Yes, sir.
16 by 15 into pi square into k into r to the power 5 into rho square is capital Q by 4 by 3 pi capital R cube whole to the power square. Correct?
Yes, sir.
Perfect. Pi
Again.
16 pi square and 4 pi whole square will get cancelled.
Yes, sir. Even R power 5, R power 6.
R power 5, R power 6 will get cancelled. My
One R
answer,
in the denominator.
I will have k capital Q square divided by r
Yes, sir.
3 square is 9 will come in the numerator divided by 15.
Yes, sir.
9 by
3 by 5.
3 by. So it is basically 3kq square by 5r is the self energy.
Yes, sir.
Sometimes he will give the problem with objective is you have options.
Yes, sir.
People thinks option is good. I feel option is bad. For me, option is bad. Sometimes in objective he will give in terms of row. Then you need to remember the number 16 by 5. Or sometimes he will give the option in terms of Q and capital R. Then I need to remember 3 by 5.
If we remember this, we already know rho equal to Q by 4 by 3 pi R.
But
So we can put there.
not all teenagers are expected to be as intelligent as. So one of the reasons why I tell no friends is because what is self energy? 16 by 15. Other fellow will say no, 3 by 5. No, 16 by 15.
Well,
No,
that's
3.
the whole thing is wrong. We're not taking the constant.
Do you understand why I say don't discuss anything with your friends? Because that fellow will remember 16 by 15. You are also remembering 3 by 5. And this is just one situation where I prove it. There are many situations. In fact, every concept in math, physics, chemistry, it's possible.
Yes, sir.
Is it clear?
Yes, sir.
If you understand it, I want you to obviously solve this twice without seeing. No doubt. You are going to solve entire class notes every time without seeing. This specifically I am saying. And in that also, when you are writing the first step, you should be sure. Remaining integration as a math student, we can do easily. But what is self energy? Self energy is the addition of all the energies that are added to the system. That addition is integration. Energy added to the system at this situation is charge added is dq into potential difference is kq by r. Okay. Hi guys. I hope you enjoyed the session. If you think this video was useful, don't forget to like, share, and subscribe to my channel. Also, I'll be waiting for your comments in the comment section. See you in the next video.